Okay, so in this section we're going to talk about inequalities. This is section 1.7 of college algebra. And we have three types of inequalities that we'll be discussing in this section. We have a linear, quadratic, and then rational. Remember, rational means fractions in math, so we're going to do some fraction inequalities. Remember, the inequality means a greater than or less than symbol is involved. So let's get started. The first one we're going to talk about is the linear inequality. And if you're following along on page 150, a linear inequality is a first degree. Remember, linear equations, they were first degree. We have an x to the first, and then maybe a and b or some real number. For example, 3x plus 7 greater than 0. That would be an example of a linear inequality. When we solve a linear inequality, we do it almost exactly like we did the equations. We solve the equation. The only difference is if we divide or multiply by a negative number, we have to flip the inequality sign around. Otherwise, it's the same old thing we were doing. You can move terms across the line, like the 7 can move across the inequality just like it did the equal sign. When it moves across that, it does change its sign. And then you can divide by whatever's with your variable, just like before. 3 divided by 3 comes out to be 1x or x. And then you always keep the balance on these just like you do with your equations. So we divide the other side also by 3. So x is greater than negative 7/3 is our answer. So same thing we were doing, just when we divide by a negative, I'll show you that in a little bit, we'll have to flip the inequality sign around. Otherwise, same thing. Alright, so let's follow the example in your book of a linear inequality. Example 1. We have negative 3x plus 5 is greater than negative 7. So to solve this, we'll treat it just like the equation. We'll move this 5 across the line, making it a negative 5. Bring the inequality symbol down. Negative 7 and negative 5 makes a negative 12. Now notice though, this time to solve this inequality, I'm going to need to divide by negative 3, because negative 3 divided by negative 3 makes that positive 1x we're always looking for. And if I divide by negative 3 there, I must do so here. That's that process I said will flip the inequality. When you divide or multiply, because they're kind of related operations, to finish that last step to solve it, divide or multiply by a negative sign, flip your inequality sign around. So x is less than 4. Now another thing I'd like to talk to you about is when we finish solving an inequality, we have the answer. That is the answer. X is less than 4, but it's a lot of things. X less than 4 represents a lot of numbers. So a lot of times they'll show that on a graph, a visual. What does less than 4 look like? It looks like 4 located on the number line, and then everything to the left of that, left is less, you know, with that. So less than 4 would be as a visual like this. The other way we express our answer is in interval notation. So another way to say that is, how far does it go to the left? We're going to call that negative infinity. It goes forever and ever and ever to the left side. So that's infinity, negative infinity. And then how far does it go to the right? To this number 4 is the boundary. And it doesn't include any number. If there's not a line under this to include the endpoint, we use a parenthesis to show that. If it has a line under it, we'll see that in a little bit, we will use a bracket instead. But your infinity will always be a parenthesis, because you can't actually touch the last number of infinity to include it. So parentheses around infinities regardless. Alright, so I like you to pause the video and always do a you try. So here's one for you. Do the same thing and then put it in that interval notation for your final step. So negative 2x plus 7 less than negative 5. So you're going to minus 7 for both sides, or throw the 7 across the line, whichever way you think about that. And then you're going to divide by this negative 2 on each side. Because we're dividing by a negative, it will flip your inequality. And a negative 12 divided by negative 2 is a positive 6. So our answer will be all the things greater than 6. So what's that look like? Locate 6 on the number line. Greater than goes to the right. So greater than 6. In interval notation, we would call that parentheses. 6 is as far as it goes left. to positive side, positive infinity for the right. All right, next example. Example 2. Still a linear inequality, but it has more going on. Okay, example 2. We see 4 minus 3x less than or equal to, that's that line I was mentioning, we'll use a bracket on this one, and 7 plus 2x. So again, we're going to solve a linear inequality because x is always to the first on linears, just like we did our equations, except the one thing I mentioned. If it shows up, we have to flip the inequality. So you can take your variables to the left or the right, just like we did with an equation. But if you take your variables to the right side, you'll have to kind of read your inequality backwards, and that can be sort of a problem. So I recommend on your inequalities to bring your variables to the left. So I'll bring this 2x over to the left. So I've got negative 3x, negative 2x, which makes a total of negative 5x on the left. Then the 4, positive 4, moves to the right, becoming minus 4. So at positive 7 minus 4, we've got 3. So far, I've done nothing to change my inequality symbol. I'm just moving things across the line, does not flip the inequality. What flips the inequality is this step. When I divide by negative 5 to finish this out, to divide and get x alone, I have to divide by negative 5. That will flip the inequality to a greater than or equal to, and then the answer is negative 3/5. So a fraction answer. All right, so how does that look on that number line that I've been mentioning? Greater than or equal to, we will use a bracket to say at negative 5/3, we're including that endpoint in our solution, and then greater than goes to the right. So I need to turn the bracket around this direction to include to the right. So that's what it looks like visually. In interval notation, we would say that's bracket, negative 5/3 to comma, infinity to the right. Positive infinity, and you know we always use parentheses or infinities because you can't actually touch that endpoint to include it. All right, so I have you try. So again, pause. I hope you're doing that and actively learning so you can practice these skills. So 3 minus 4x greater than or equal to 2x plus 8 is your you try. So again, that is 3 minus 4x greater than or equal to 2x plus 8. So similar to what we just did, we'll want to get our variables to the same side. So I'm going to bring my 2x to the left, making it minus 2x. And I've got negative 4x, negative 2x, so I've got negative 6x on the left side. The positive 3 needs to go to the other side, making it a minus 3. So I'll have an 8 and a minus 3, or 5 on the right side. It's a greater than or equal to. And then to solve, I do need to divide by this negative 6, just like before. Dividing by the negative flips my inequality. So this becomes a less than or equal to negative 5/6. Drawing that on a number line, less than is going to go to the left, so I'm going to make my bracket head to the left, and see it's a negative 5/6 for my boundary point, and then less than goes to the left. X is less than, so less than is left, and that's what it would look like. Interval notation, we'll say that's negative infinity up to the right is negative 5/6, including it because of the line under the inequality. All right, moving on, then the last type of linear inequality we have is this three-part inequality in example 4. So notice on example 4 we have a negative 2 less than 5 plus 3x less than 20. So it's called a three-part inequality. You've got this section, and this section. You've got two inequalities involved. So some people do it by pulling them into two problems. They'll say, look at that as a problem, and then look at that as a separate problem. So you can make them into two problems. That's one strategy. This book, and what I normally do, is I leave it intact as a three-part inequality, and I work from the middle. I want to get x alone and say x is between the two endpoints. So I'm going to keep x in the middle, and then keep the balance on the 3 parts. So I'm minus 5, this positive 5's got to go to get x alone in the middle. So I'm minus 5 from all the parts, and I get negative 7, 3x in the middle, and 15 on the right. Then I want to get x alone, still working towards that goal, by dividing by this 3, the 3 in the middle. So divide everything by 3. And now we have x isolated as regular x in the middle. It's less than 5. And then greater than, if you read it from x's perspective, x is greater than negative 7/3. Or we can think of it as saying x is between negative 7/3 and 5, a between answer. So on our number line, how will that look? The answer is all the things for x that's between negative 7/3 to positive 5. Notice there was no line under these inequalities, so neither one includes the endpoint, just parentheses, and then everything between that. So in interval notation, we write negative 7/3 to comma positive 5. That's our final answer. All right, so now you try that. Okay, your problem is 1 less than or equal to 6x minus 8 less than or equal to 4. So I'll start by getting x alone in the middle by adding 8 to all the 3 parts, keeping the balance on 3 parts now. Minus 8 and plus 8 cancels to leave it a little more reduced, just 6x in the middle. 4 and 8 is 12. 1 and 8 is 9 on the ends. Then divide by 6, so we'll get x alone in the middle. Divide by 6 on the other 2 parts, keeping all the balance. 9/6 could be reduced to 3/2. We should do that. Reduce any fractions. And then 12 divided by 6 comes out to a nice even 2. Alright, so our answer is x is between 3/2, and this time I'm going to use a bracket. Notice the line under it, and these could be different on each one, but both of these are lined, so I'll use brackets for each endpoint. So 3/2 to positive 2. And it's all the numbers between. X is the numbers between those 2 endpoints. Then in interval notation, we write it almost just like it looks on the graph. So it always helps me to kind of draw the graph. You might not be instructed to do that in your homework, but it just helps me to visualize it. I find that I use that step to then write my interval notation. So 3/2, comma, to 2, again, both with brackets. That would be my solution set. Okay, I think I'll pause there and then come back in on the next video to talk about the quadratic inequalities. But that would wrap up the type of linear inequalities that you would see. All right, be right back.